Alright, so first of all, we talked about arrays and two-dimensional arrays. Now we're going to get into the collections framework. But before we actually get into various collections, we need to know generics and wrapper classes. So we need to know what generics are and what wrapper classes are. So to represent generics, we have to create a class, let's just say. Let's just say you have a array. Let's say we have a display. Let's call this display sys. So, and then of course we have, let's just say you have a private string line. And then you have our constructor. Then line equals L, and of course string L, basically. And then we have our toString, string to string, return line. Now, of course, we need our main method, which is already in the generics class. We're gonna talk about how to use generics quite shortly. So D1 is what we're gonna call the object equals new display sys, basically. And we're gonna take in hello and system.println D1. If we run, then we should be able to print hello. Then how are you doing? Alright, so although this is good for restricting a data type, you'll have to change the internal code consistently if you want to display a line of code using different types, and that's where generics will be useful. So in order to make a generic, you will go to your class header. So after the name of your class and before the opening bracket, you will do an opening and closing tag along with what you want to call the generic. We're going to call this T, but you can call this generic anything else. So what you can actually do is do T, and then you can do T line, and then this is type T, so this refers to any type. So this could be string or boolean, and since we're using TL, I mean that same type will work in the constructor. Now we have to change the toString a bit. So we can just add an empty string. That's how we're able to fix this. So of course, right now here's how it will go. How are you doing? Right now we're just doing a string. Let's just do an integer. Sure, here we go. Now of course, if we want to enforce the data type change, we put tags after the class name and before the object. So let's say we want integer, and we also put 2 tags after. You could also include the integer tag afterwards, but of course, it's not really necessary, it's optional. Anyway, but here's what happens if we try to do another value. As you see, we get an error. It's saying that required type is an integer, while the value provided is a boolean. So, only way we can do this is change it to boolean. At the same time, we gotta change this also to boolean. However, yeah, and that is very good for restricting all these data types as well. And that is originally how we use some sort of generics. So now we're gonna head into specifically some wrapper classes. So I'm actually gonna create a new class called wrapper classes. So there are a few wrapper classes for each data type. There's int, integer. So ints can be written as integer a equals 6. And of course, we call this new integer 6, although you could declare it right here, it is now deprecated. However, it is now deprecated, so we can just call this integer a equals 7. Let's just do double. Notice that how the double wrapper class is capital, so let's call this integer I, double d equals, and then of course we have boolean b is true, and then we have shorts s, bytes by. We're gonna call this by because let's call this 3. Then we need another data type. We have long, L equals very much a long number. We have integer, we're missing character, and of course we're missing floats as well, floatdef. Here we go. And that is supposed to be all the wrapper classes. Originally, all the wrapper classes must be used in using generics, and it's very useful for casting. And keep in mind that these types can be casted, so you can cast from a primitive int to a wrapper int to an integer class instance, basically. So now we're going to talk about how these are useful. So we're going to get an error if we do the primitive type. Type argument cannot be a primitive type, so therefore we use the wrapper classes. And that is basically an overview of generics and wrapper classes. Now we're actually going to head into overview of the collections. Now of course, the three main collections are list, queue, and set. However, in this series, we will also cover maps as well, since sets and maps are nearly related. Alright, so first of all, let's make our main method here. And let's get into some collection writing. So, of course, we talked about arrays. We can now use lists. Lists are very much the next thing we talk about here. So in order to make a list, we first have to import the java.util package. We import everything because we also cover queues, maps, and sets. Alright, so to create a list, we first have to go ahead and do list, and of course there's an option right here. We do list list equals new. We can't do new list because it's an interface. List is an interface basically. So, and of course we can't instantiate type list basically. We have to do a class that implements. Alright, so such examples are ArrayList and LinkList. So let's call this ArrayList. And there we go. And again, we should probably restrict data types using generics. So let's use integer. And even if you didn't restrict the data types, the list will be of default object basically. The elements will be a default object basically. So you can add any type. So there are a few things you should consider. Of course, we're going to talk about lists in detail. Again, so there's an add, list.add. We have 2 add methods. We have 6. And of course, let's copy paste it here. But we're going to talk about list more. We have list, and then we have 5, 4, and then 3. If we want to display, we system.println list. And of course, we do... Hold on, I didn't mean to go in generics, my bad. Okay, so very much, alright, I'll just add in a value then. Alright, so here we go. got 6.43. Here we go. Now, of course, we want to remove values as well. List.remove. There's an object O, and we have int index. Again, we'll talk more in detail. So we have remove 1, that's the index. If you remove the first index, 5 should be removed, and we should print 6, 4, and 3. Now, here's the list essentially. Next, we mainly talk about queues. Queues are the next thing we talk about, because queues are basically the next step that you'd usually do in data structures and algorithms. Alright, so now we talk about queue. Queue and then E. E and then Q equals, not E, I think, let's just call this string. Q equals new. We're gonna call this, so of course, right here, this is probably an abstract class, so we can't do this. So there's an array DQ and a linked list. So we're going to call linked list here. So right here, we're gonna add values to the queue. We can only add values. Since queues are not ordered, or particularly, you can only add values from one end and remove from another end. So you just do add, then let's just say Carl right here. It's got Joyce, Butler, then we have Aryan, and then Jaden. We're going to display the queue every time. So we just do system.println queue, and it's going to print the entire queue. Basically because it's basically the class has a toString. So now we want to remove. So of course offer. We're actually going to do offer here. Because even though add does the same thing, or similar thing, offer is just somewhat different. So now we just go ahead to, so as you see, Carl should be added in first. So I believe Carl should be added towards the beginning basically. So now we add Jaden in, and if we do q.poll, poll basically means that we remove the last item. So as you see, Carl should be removed. If we run it, then we should see Carl removed on the 6th line basically. Here we go. And that is essentially operations with queues. Next we talk about sets. Next we're mainly going to talk about sets here. I'm not going to talk about maps because we running low on, because I don't want to take too much every time. So let's talk about how to use sets here. So of course we have sets. Let's just say we have type I'm trying to think. So we have character. Let's say we have a character set, and then we have set equals new set, not set. So there's a hash set, and then we have a tree set. Let's use a hash set basically here. And essentially sets are unordered. So set.add, we have t, and then we have, let's say, TRAINN, basically. And keep in mind that sets and maps do not allow duplicates. Maps specifically do not allow duplicate keys. And sets do not allow duplicate values, since there's only one value. If we want to display the sets, then we actually just print the set, like we did last time. So we did TRAIN, and as you see, the elements are actually in a random order, but they're actually in a fixed order relating to hash code. So of course, the order goes by their hash code, not in alphabetical order. It prints as ARTIN. If we try to do something else, we have a tree set. Tree set here. If we want to print it, so AINRT. As you see, it's different. Then, and likewise, you have the linked hash set. If we run it, then we will get the entries in the exact same order. Thank you all guys for watching, and see you in another video. Bye.